Okay, everyone, welcome back to Backend Magang. Stay humble and keep the excitement to learn like a newbie intern. Okay, before we start, of course, I would like to thank you for you all for supporting me by subscribe, like, and share. And um, so for today, let's be honest, we all want our application to run fast and we want our APIs to respond in the blink of an eye. Yeah, but sometimes those massive performance improvement don't come from grand. It's like it's complicated change, but nope. They came from a small tweaks that make a huge difference. So yeah, today we are going to explore how just a few small optimization can make a big impact on your app's performance. And yeah, without further ado, let's get it on.
Please like, share, comment, and subscribe.
Yeah, why do small optimization even matter? So imagine you are building a backend for an e-commerce app. Thousands of users could be browsing at once and adding items to their cart or checking out perhaps. And yeah, if your backend takes forever to respond, those users won't be very happy, of course. So with just a few tweaks to your code, we can speed things up and in this case, we need to talk about caching and concurrency. So the first one is caching. So caching is a small but powerful optimization. Instead of calculating the same data every time a user requests it, you can store it temporarily and pull it from the memory next time. So this will dramatically improve our app's performance. And after that, the concurrency allow us to run multiple tasks at the same time. With Golang's goroutine, we can make things run faster by handling multiple operations concurrently. So yeah, without waiting for one to finish before starting the next. Okay. Let's break down with some code to show you exactly how these small tweaks work. So we will build a simple Golang API that handles data processing requests. And now you think it's just a simple API. What difference can this make? We are going to make it run more efficiently by adding caching and concurrency, and you will see how the small change can have a big impact. So let me walk you through the project. So for the project, we just make a simple project like the structure. So we just have a main.go as the main program, and then we have the directory utils, and inside the directory util, we have a file named catch.go. Okay, the first one, the simple case. Yeah, we will talk about the catch, and here's how we start the project by defining our catch and how it works. So as you can see on my screen, so this is a simple code implementation for the case. We use a map to store data and to make sure things don't get messy when multiple goroutines try to access the case. So we use mutex or mutual exclusion for thread safety. And the caching here is key because it allows us to store the result of a heavy operation like processing data and retrieve it without recalculating it every time. So this is a huge performance boost, especially when dealing with repeated requests for the same data. And the advantage here is speed. So data stored in memory is retrieved much faster than recalculating or querying a database. And after that, we will look to mine.go. So let's look at how we create the API and how we introduce concurrency to speed things up. So as you can see on my screen, this is the mine.go. So in this code, the API checks if the data is already in the case. If it is, it returns the case data, so no processing needed. And if the data isn't in the case, we process it using the process data function, and which simulates a time-consuming task. So yeah, this is example but a complex calculation or database query. It's just for the demonstration only. Okay. So after that, we use goroutine here to process the data concurrently. This means the main thread doesn't have to wait for the data to finish processing. It can go on doing other things while the goroutine does the work in the background. So what makes this a small but a big change? So here's the magic. The case and concurrency are small tweaks, but they have a huge impact on performance. So the first one is the case. So about the case, instead of processing the same data over and over, we store it in memory and reuse it. So yeah, this will drastically reduce the processing time and server load, especially yeah, with repeated requests for the same data. And for the concurrency, the Go routines, by running the data processing in the background with Go routines, we can handle multiple requests at once, and yeah, instead of processing each one sequentially. So this makes the feel faster and more responsive, even when there's a heavy load. So I will show you the real code in my code editor. Okay, this is the kids.go. So as I told you before, we just make we just using the map for this cat store data. This is the method for get, and this is method for set the data store, and this is the main process. Yeah, as I told you before, we use the time slip. 100 time millisecond is just for simulate the delay process, like we calculating some process and we querying a database. So make this for demonstration only. Okay, this is the function get data handler. In this line, I check is the data is in the case or not. Okay, I'll try to run this project. Okay, I will hit the API like this. Okay, data process and process data ID is 1, 2, 3. But if I hit it once again, yeah, voila, catch hits and process data ID is still the same, but the time is 7 milliseconds. So it more faster and it boosts the speed for our apps. Okay, yeah, I hope you understand what I show you regarding the caching process and the concurrency process. Okay, I will back to my presentation screen. Okay. Yeah, for the real world use, yeah, well, this implementation works well for demonstration. In real world application, you would typically use Redis or Memcached or another dedicated caching tool. These tools are designed for scalability and can handle distributed environments where multiple servers share the same cache. So yeah, Redis, for instance, is a great option because it supports advanced features like data expiration and persistence, making it a powerful choice for production system. Yeah, now let's wrap this up with some real talk. Yeah, small optimization like caching and concurrency can have an enormous impact. These aren't complex algorithm or expensive infrastructure change. So yeah, instead they are simple choices that can significantly improve your app's performance. So yeah, don't overlook these small tweaks. They can save your time, money, and a lot of frustration down the road. Just like cleaning up your desk doesn't involve buying new furniture, but rather organizing the stuff you already have. Optimizing your code doesn't always mean reinventing the wheel. So it's about making smarter use of what's already there. So yeah, next time you're working on a project and think this is good enough, yeah, ask yourself again: Can I optimize this even a little bit? Because those tiny tweaks could be different between a sluggish app and one that perform like a speedster. So yeah, thanks for joining me today. If you enjoyed the video, don't forget to hit that like button and subscribe for more backend magic. Let's keep optimizing one small tweak at a time. And once again, thank you very much. Cheers, backend maga.